Well, thank you very much. I really appreciate the opportunity to be here today and visit with you about some work that we've been working on for the last little over 4 years anyway, at this present time, and it's still continuing. I'll admit to being a little intimidated because university professors probably shouldn't be up trying to teach people in the swine nutrition business how to feed pigs, okay? I think all you guys know more about feeding pigs than I do, okay? But in any event, what we did in this particular case is that we wanted, and I want to spend the time today addressing this decreasing of crude protein, amino acid supplementation on performance in carcass, and as he indicated, in carcass and nutrient excretion. And you can see this is the work I'm presenting today is primarily a cooperative work between Purdue University, University of Arkansas, and we had several people involved in this. And this is supported by a grant from the USDA, one of the NEFA-AFRI grants. And it's climate change mitigation and adaptation in agriculture. So the first question you might ask is, how in the world do you go from climate change to feeding different crude protein diets in pigs, okay? And so at the time this RFP came out, we were working at the University of Arkansas with the Port Board on an LCA, and which is looking at the carbon footprint, the factors involved with carbon footprint in pig production. And it turned out a couple of the factors that were highly associated with carbon footprint was the diet of the animals and the manure. And the part that I chose to work on this is to evaluate the possibilities of optimizing feed-grade amino acids to reduce the dietary crude protein in the diet, and how that might impact nitrogen excretion in swine. And so the rationale for this is quite simple, actually. Nitrogen compounds have more impact on carbon greenhouse gas effect than does CO2, 298 times the effect, in fact. And it also happened to be the time that we were moving from the phases where we added 3 pounds of lysine per ton and added 100 pounds of soybean meal. We'd finally gotten over that. And we're having more amino acids available to us. So at the time we started this, we certainly had 4 amino acids available on a routine basis. And today we have increasing amounts of valine, and I think in the future, shortly in the future, we'll have isoleucine available to consider the possibility of adding it in swine diets. So we chose to look at the 7th limiting amino acid, which is histidine, and take a look at, can we go that far in formulating diets based on the 7th limiting amino acid, and then add the feed-grade amino acids back to those diets and keep the same performance. The other aspect of all of this is that, well documented in the literature, that if we can figure out a way to feed less protein in the diets with a more balanced amino acid ratios, we can definitely impact nitrogen excretion. So our hypothesis was that we can, in fact, optimize amino acids in pig diets and reduce crude protein in those diets and reduce nitrogen excretion and greenhouse gases in pig production. And so our objective then was quite simply to determine how far we can go in reducing crude protein in pig diets and adding back amino acids. And in nursery trials, we looked at growth performance, and in growth-in trials, we looked at both growth performance and carcass composition, fatty acid composition. We've also looked at a few of the gender effects, and in all the cases in the growth-in areas, we're feeding paline in the final diet. So today I want to summarize results of 2 nursery studies, 3 growth-in studies, and 1 nitrogen balance study. The first nursery study was looking at 5 different treatments. In all of the cases in the University of Arkansas work, it was PIC C29s by 388 males. In the nursery trials, we weaned pigs about 21 days of age, about 6.5 kilograms. In this study, we had 8 replicates with equal sex in a pen. And we had 3 dietary phases, and in this diet, we conducted the study as a ratio study where we fed, because we didn't want to have excess lysine in the diet, so the diets were fed at 95% of the SID lysine in this particular study. So the treatments were actually quite simple. We started with a corn and soy diet, or a corn soy DGS diet we'll get to in a minute, with no feed-grade amino acids added. And we titrated the addition of amino acids to those diets by adding lysine hydrochloride in equally spaced increments. And at the same time, that reduced crude protein. And so our total reduction in crude protein in those diets were somewhere between 28 and 38% reduction in crude protein. And this particular study was conducted in our wean to finish facility at the university. The nursery diets we used were what we think is fairly typical of industry diets. Moderately complex phase 1 diet. We left whey and plasma in the diet all the way through, and we titrated poultry meal and menhaden fish meal to 0, and then also reduced soybean meal in those diets. The ratios that we use, and note that this was work that was conducted in the references we were using in terms of requirement, was a PIC manual in 2011, because this was shortly before the Swine Nutrition Guide came out and shortly before NRC 2012 came out. Anyway, these are the ratios that we use in those studies, and in all cases, with the exception of one, a notable exception of one, we added the amino acid to lysine ratio at 2 percentage points above the requirement. We didn't have histidine, so in fact we didn't do that, and the calculated histidine level in our diets was below the recommended level in the diet. Phase 2 diets, the same scenario. Reduced poultry meal, same scenario here, and again we had a below the requirement for the histidine-lysine ratio, or the estimated requirement for histidine-lysine. And phase 3 diets, we were simply working with decreasing lysine, or increasing incremental units of lysine and only decreased soybean meal, and the same scenarios on the ratios, okay? So the results of this particular study were that we got a quadratic response in all cases. However, if you look at the nature of the quadratic response, it's primarily due to an increase in performance during at the lower levels of amino acid inclusion in the diets. And even in phase 2, there still is a very little reduction at the highest level. However, at the phase 3 and overall, we got a decreased reduction in performance in pigs fed the diet with the highest amino acid inclusion in the diets. Looking at average daily feed intake, we got the same types of responses, and that we got a quadratic response, except in each one of these cases, even at the highest level, we still have improved average daily feed intake over pigs that were fed the control diet. So we got an increased level of intake with the addition of amino acids in the diet. Gain per feed is a little bit different story. We saw a similar type quadratic response in phase 1, no significant effect in phase 2, but in phase 3 and overall we saw a linear reduction in feed efficiency as we increased amino acids in the diet at the expense of the protein in the diet. And pig weight, you might expect, would do the same thing. We had a reduction in pig weight starting at the end of phase 3, very similar pig weight at the end of phase 2. So the conclusion of this particular study was that as far as overall body weight and average daily gain and efficiency gain were similar or improved at a lower inclusion level of amino acids, but they declined at the higher levels of amino acid inclusion. And then average daily feed intake, we got a quadratic increase with amino acid addition, but we did see a small linear reduction in feed efficiency with amino acids. So we wanted to go back and conduct a second trial and correct some of the mistakes that we think we made in the first trial. And those corrections that we made in that, so we wanted to adjust some of the ratios. And we had conducted a growth-in trial with diets calculated on any basis, and we thought that that helped improve some of the increased fat deposition in pigs fed to higher levels of amino acids in the diet. So we wanted to go back in the nursery trial and compare ME versus NE formulation procedures. So we chose the diets from the previous study, diet 2, which, if you remember, diet 1 is simply no amino acids added, and our logic was that everyone's going to use some small amounts of amino acids in swine diets, and so we went to the treatment 2, which met the tryptophan requirement without added tryptophan in the diet. And again, this particular diet was on a metabolizable energy formulation procedure. And looking at the ratios in trial 1 was fed at 95% of the requirement, trial 2 was 100% of the requirement. We used the same ratios with exceptions, about 3 notable exceptions. The tryptophan to lysine requirement was increased to 20 based on some data that we had, as well as some data out of K-State. The valine ratio was increased from 65 to 70 in phase 3 based on some data out of Europe. And then in this particular case, as far as histidine is concerned, we obviously met the histidine requirement and got away from having the reduction in histidine requirement, reduction in histidine in the diets. We ended up with, again, essentially equal sex in a pen, 7 reps per treatment, roughly the same weight pigs to start with in this trial. In this particular study, we got exactly what we wanted to get, which is no difference in performance in terms of average daily gain, very similar performance across phase and overall as far as average daily gain is concerned. Same thing with feed intake. In fact, I think if we ran a uniformity study, we couldn't get numbers any closer to this in terms of equal performance. So every once in a while, when you don't get a difference, it's what you're looking for. So that's good to know. Gained feed, and again, we eliminated the negative thing that we saw with gained feed in the formulation of this diet. And note that in all these cases, there was no difference in the diets formulated, the reduced crude protein diet based on ME or NE in these diets. Okay? And as you might expect, body weight. So conclusion for this particular nursery trial is that we did get similar performance out to the 7th limited amino acid, which is histidine, and providing feed-grade amino acids to meet the SID amino acid requirement. And we didn't see any difference between ME or NE formulated diets. So I think that tells us and I'm not talking about the economics of all this today because it's certainly probably not economically feasible to feed out to that level. But I think it gives us that flexibility of feeding out to the 2nd limited amino acid and formulating our diets on that basis and see what does, in fact, give us the best cost-benefit ratio in feeding pigs. So we know what the limits are, I think, in terms of being able to do that. Now, I'm not ready to go take this to the bank yet, quite. I think we still need to know with the same, do we get the same answers with different diet, different feed ingredients, different institutions? Arkansas pigs might not be able to perform as well as other people's pigs around the country because we've got a lot of razorback breeding in them, okay? So, okay, same story on growth in. So same scenario. We started out with growth in diets. We controlled diet with no feed-grade amino acids added. 4 additional reductions in crude protein diets. Diets were formulated on ME basis. And we wanted to evaluate the effects of gain, intake, and feed efficiency and carcass composition in pigs. And again, same genetics that we were using before. There were allotted pigs to 6 pigs per pen. And these were gender-specific pigs, a separate gender trial, okay? So within gender and blocks, pigs were assigned randomly to 1 of 5 dietary treatments. So we did look at the sex effects in this as well. The diets that we fed, and these are just the control diet, a corn soy DGS diet, and we didn't put any DGS in the final phase diet in this particular case. We met what we thought was the SID lysine requirement of our pigs in our system, and all the diets were formulated to the same ME per kilogram, and we had 0.03% paline in the diets. And I'll only show you one of the diets here, or talk about one of the diets here, and that is the growth finisher phase 1, formulated again to meet all the SID estimated requirements based on PIC's recommendations. And we added 2 percentage units above the estimated recommendation for everything except for histidine. But in this case, we did in fact meet the histidine requirement. We just didn't have histidine to add to the diet to formulate them at 2% above that. And all the other other 4-phase diets were formulated and calculated on the same basis. As before, they were all calculated on 95% SID lysine requirement, and these diets did meet the SID ratios except for histidine. Paline was fed, and we did have soybean meal in all the diets, although the highest level of amino acid substitution had very little soybean meal in the diets. We looked at feed intake in pigs. We used ultrasound procedures to estimate the back fat thickness in these pigs at the end of each phase. And we selected 3 gilts and 3 bearers at initiation to start this process so that we could actually estimate lean tissue gain in pigs throughout the study. And then at the end of the study, pigs were harvested at a slaughter plant, measured the FOM data, tenth rib fat, loin depth, and heart carcass weight in these pigs. And the results of this is, from our first look, was we thought quite disappointing actually, because we would like to see very much level bars across all this, okay? But unfortunately, we observed a linear decrease in average daily gain in the first phase, some tendency for a reduction in gain in the second phase, back to being a linear reduction in phase 3. So in the earlier phases, we saw reductions in average daily gain. Overall, that resulted in a quadratic response. So the primary driver in all these cases is that at the highest level of amino acid supplementation in the diet, we ended up reducing average daily gain. Average daily feed intake, similar story in that we saw in certain, but not as prevalent as average daily gain, but we saw a tendency for a linear decrease in average daily feed intake, and in phase 3 or finisher 1. And we observed a linear decrease overall in average daily feed intake.
So the ratio in 4 for cysteine was 32, but what was it in 3? I can't remember. You went down. As it went left to right, it went down.
The ratio of histidine to lysine?
Yeah.
No, the minimum ratio in all these cases was maintained at 32, okay? So.
But they ran, I thought they, like 3 slides back, I thought they were running over.
It's more than 3 slides back. Anyway, they all met the 32.
Yeah. Oh yeah, at least 32.
At least 32, okay, and yeah, and in fact they were formulated to meet that 32, okay. And in gain to feed, we also saw a linear reduction in feed efficiency as we increased amino acids in these diets. Except in finisher 3, this linear is not a reduction, it's an increase. And so, and I think this fits with where we'll end up with the whole amino acid story. I think there is the possibility that we can actually improve efficiency in diets with increasing levels of amino acids in diets. And we've seen that at the, in some phases in feeding pigs, and we saw that here in phase 3 in the finisher pigs. Overall, no effect on gain per feed in this finishing study. We did see some gender effects in that gilts tended to increase efficiency in finisher 3, and then decreased at the low and moderate levels, and then decreased gain to feed at the higher inclusion of amino acids. Bearers basically did not respond, and we saw the same thing overall in the overall data pool, which essentially gilts giving a better response to that and bearers not responding to increased amino acid. Now the big problem we have with this particular study in terms of from a disappointment standpoint, on our standpoint, again, because we're trying to show that we can in fact raise pigs on get the same performance with high level inclusion of amino acids in the diet and reduce nitrogen excretion. Well, unfortunately, we observed a linear decrease in fat-free lean in pigs fed increasing levels of supplemental amino acids or feed-grade amino acids in those diets. And this is one that's been reported fairly consistently in the literature, and we certainly observed it here, and that is the 10th rib fat depth increased as we increased amino acids in the diet or replaced soybean meal with amino acids in these diets. Also interesting to note that the intramuscular fat tends to increase, and generally speaking, that's primarily an effect of BARA. In fact, there is a treatment by sex interaction between bearers and gilts, with gilts not responding in this particular study, whereas in bearers we saw an increase and we have seen some increase in marbling, and I guess in our hands marbling is more difficult to measure than intramuscular fat, and we get more consistent results with measuring intramuscular fat in these pigs. Okay, so what we concluded from this study was that when we ran studies that way, reduced average daily gain, at the highest substitution level particularly, decreased gain to feed, particularly in the earlier phases, and we increased fat and we decreased lean. And we had stakeholder meetings in this whole thing annually on this project, and one of the things suggested by the stakeholder group that we're meeting with was that we might want to consider formulating diets on any basis instead of an ME basis, and in fact that's what we did. We came back and ran a second study looking at ME versus NE. And if you go back to our, and this is just a calculation on the phase 1 diet from the previous study, we obviously fed them at the same isocaloric value, same grams of lysine per megacal. And if you take those same diets and calculate it and transfer it to a net energy basis, you can see that there is an actual reduction in the grams of lysine per unit of net energy as we increase adding synthetic amino acids or adding feed-grade amino acids to these diets. And this is the result here of phase 1, and it was about a 6% reduction. And you notice that we observed similar type reductions in all 5 phases. So we are, in fact, on a calculated basis anyway, we're reducing the lysine for energy if we calculate these diets on a ME basis. So we formulated some diets then using the same energy values that we'd used in the previous trial. And they were isocaloric within phase, and we formulated them from ranging from 4.23 to 2.67 grams of lysine per megacal in this particular study. And the second objective of this study was to take an approach of setting a set point for amino acids and formulate to meet the SID amino acid requirement and adding feed-grade amino acids. And the example that I would use for this is that if we set the tryptophan set point, diets will be formulated to meet the SID tryptophan lysine requirement without feed-grade tryptophan. And that's what we are defining as tryptophan set point. The same thing's true with histidine set point, okay? And we met all the SID amino acid to lysine requirements in the process in this particular study. In this particular study, we had 9 reps of treatments, again, mixed sex pens in this particular case. So we took treatment 1 was set at the tryptophan set point. And again, we simply met tryptophan without any additional tryptophan. We look at the next limiting amino acid in these diets, treatment 2. In phase 1 and 5, valine was the next limiting amino acid. And in treatment 2, 3, and 4, isoleucine was the next limiting amino acid. And in all these cases, we added tryptophan back to the diet to meet the correct tryptophan to lysine ratio. In phase 3, the diets that were deficient here, or that where valine was the limiting amino acid, then in this phase, isoleucine became the next limiting amino acid. So we added valine in phase 1 and 5, whereas in the diet in treatment 3, where isoleucine was deficient, valine then became deficient, and so we added isoleucine back to those diets. And then the final treatment was to look at histidine set point, where we simply met the histidine requirement without any feed-grade histidine in the diet. This resulted in a little bit of, in our opinion anyway, a little bit of improvement in terms of the variability that we saw in the study. But it still left us with some issues out there relative to gain, and it's almost totally driven in these cases by the highest inclusion level. Up to the valine and isoleucine set point, there's not very much difference at all in animal performance in pigs fed these amino acid-based diets. Same thing's true with average daily feed intake. No differences in average daily feed intake in the first 3 phases. However, in the phase 4 and phase 5, we saw the same scenario of substantial reduction in feed intake at the highest inclusion level. Interestingly, gain to feed in this particular study was essentially a wash. No real major effects on gain to feed. In fact, there's a slight improvement, a quadratic improvement in gain to feed in pigs on the phase 1 diet in this particular study. Body weight, as you might expect, based on the gain data, a reduction in the pigs fed the highest level of amino acid inclusion in these diets, and very similar body weights in the other cases. Carcass standpoint, same story as you might expect. We did observe a decrease in hot carcass weight. Pigs were just simply lighter, and pigs fed the highest level of amino acid, feed-grade amino acid addition to the diet. Calculating on a net energy basis, I would say that we came closer to meeting the energy to lysine requirement in these pigs, and that we did not see that increase in fat deposition in these pigs that we observed in the first study. However, in pigs fed the next to the highest level amino acid addition, we still saw some increase in intense real fat in those pigs. So we didn't completely solve the problem, but it's certainly not as great as it was in the previous studies. It's also interesting to note that some fairly dramatic changes, at least they appear to be dramatic to me, they might not be to you guys that are killing pigs on a daily basis. We observed a saturated fatty acid, a linear increase in monounsaturated fatty acids, and a linear decrease in polyunsaturated fatty acid, and that drives the calculated IV diet down about 3 points. Compare the control with the reduced crude protein 2 and reduced crude protein 3 diet. So the substantial reduction in iodine value in adding amino acids, and I never expected to see feeding different levels of amino acid to have that impact on fatty acid composition in the carcass. We observed in this particular study a trend for increased intramuscular fat with no sex interaction either. So our conclusion with this study is that we think we can go to the 6th level amino acid, either valine or isoleucine, provide feed-grade amino acids, and reduce crude protein to diets by about 23% or 24% without impacting gain. However, when we go to histidine and add back those 6 amino acids before that, we get a reduction in average daily gain in these pigs. So getting our collection of wisdom together in terms of why we might be seeing that response, and we keep getting tired of keep running these trials where we get the same answer, okay? You think eventually we would learn that we keep running those kind of trials, we might expect to get the same answer forever. So the question is, why do we see that reduction potentially in performance in pigs fed the highest level amino acid diet? Because I think all you guys probably took the same protein metabolism classes I took in grad school, and they tell you if you meet the amino acid requirements, it should be the same performance in pigs fed. So amino acid, no matter where it comes from, right? Okay, so we should do that. We weren't able to do that in our previous work. So now, is there some problem with the ratio? Is one scenario that's out there I think that we might want to address. Diets might not meet the minimum nitrogen requirement. We might simply run out of nitrogen to synthesize the non-essential amino acid. And then I think the other part of the equation out there is that we may be interfering with electrolyte balance in these particular studies. And this particular study is not in your report because we just completed it, and it wasn't completed at the time I put this summary together. So we came back and ran another trial looking at the same controlled diet that we'd used before, which is a tryptophan set point, and treatment 2 was the same histidine set point that we'd used before, where we added 6 amino acids back to that. Treatment 3 was a little bit of a unconventional approach, I guess you would say, in that we added all the essential amino acids back to the same level as the control. Treatment 4, we added nitrogen back in the form of glutamic acid and glycine, and the ratio of glutamic acid to glycine was 2 to 1. To the same level as the control. We added that on top of the essential amino acids. And then we came back with a final treatment where we added back, treatment 5 was the amino acids, corrected for the differences in MEQs in this particular study by adding sodium bicarbonate to make the isoelectric point the same in these diets. And that's back to control. So all this was added on top of, additively to these particular diets. And results of all this actually is a little bit more encouraging, I'd say, in that we only observed, and why it only shows up in phase 3, I don't know, and overall, but in phase 3 and overall, we saw the same reduction in gain that we had seen in the previous trials that we'd run. And that was completely restored by adding the essential amino acids back to the diet. And there was no additional benefit. In fact, one could argue there might be a slight reduction in performance by adding back the non-essential amino acids and adding back the sodium bicarbonate to those diets. We didn't see any additional response. A little less responsive was average daily feed intake, but we did see that in phase 3, same scenario where we got a reduction in average daily feed intake, completely restored by adding the essential amino acids to the diet. Gain per feed, same scenario that we'd seen before. Reductions in phase 3 was significant. Overall, it was significant, and completely restoration then with no additional benefit with adding non-essential amino acids to the diet. In body weight, as you might expect, it's the same scenario. Starting in phase 3, we have a difference in body weight in pigs fed the highest level of amino acid addition to our diets. And that was completely restored by adding the essential amino acids back to the diets. Okay? Now, those of you that are thinking about making money running these kind of trials, they tell me that the amino acid cost in this trial was $22,000. So I don't think we're going to make a lot of money raising pigs, feeding those levels of amino acids. It's also interesting that the carcass composition in this particular study, same scenario, we got a reduction in hot carcass weight that was completely restored by adding the feed-grade amino acid to the diet. And dressing percent was same across all treatments. Fat-free lean's the same, long muscle depth the same, 10th rib back fat the same across all treatments. So based on this final study, I think the reduction in growth performance and carcass characteristics that we observed in pigs is probably due to some incorrect assumptions relative to the amino acid ratios. And I think we did show that there was no additional benefit to adding the non-essential amino acids or sodium bicarbonate to correct for the isoelectric point. And what that tells us, I think, from a research standpoint in the next few years is that we need to start continuing to take a look at optimizing the amino acid to lysine ratios. We know a lot more about the first, second, third limiting amino acid in pig diets, a lot less about 4, 5, and 6 limiting amino acid, and I think we need to know more about that. But I think the good news is that once we get that corrected, I think we can look forward to doing the same thing that I'm suggesting that might be possible in nursery diets, and that is to meet the 7th amino acid requirement and allow modeling programs to best assess what's the best profit system in our systems. Okay? We also conducted a nitrogen balance study. At Purdue University, using 16 bears and using the same control diet with no feed-grade amino acids, 1, 2, and 3 time reduction. And what they observed in this particular study, compared to control versus the highest level of amino acid inclusion, there was a 36% reduction in nitrogen excretion. And they also observed a linear decrease in volatile fatty acid excretion in these pigs. Okay. So that's our story. I certainly want to thank the 3 primary amino acid supplying companies for their supply of helping us with amino acid supply for these studies, as well as financial support to allow us to get the carcass data associated with these studies. And I also want to thank 3 individuals that spent their whole day meeting with us in Kansas City about 5 years ago to sit down and help us put together our matrix in terms of our calculations and the recommendations in terms of how we would go about formulating these diets. Where are we headed next with all this is that there's a study that's almost completed at Purdue University in their swine experimental research barn, where they are able to look at performance in pigs fed similar type diets in larger pen units, and they're also able to look at the gas emissions on a pen basis. So we'll have a lot better story to tell relative to the impact this is having on the gas production. Okay? We're also interested at the University of Arkansas and have taken samples from these pigs on the last trial to try to take a look at what's going on in terms of muscle protein synthesis of these animals. And is there a difference? And I would suspect that there probably is a difference. And as you'd expect, if you're not meeting amino acid requirements, you're going to have a reduction in protein synthesis of these animals, and we should be able to show that. We have a tryptophan-lysine ratio study underway at the University of Arkansas at the present time. So additional ratio studies are needed, I think, in our system, and we're planning to take a look at additional ratio studies in terms of how do we optimize or at least minimize the reductions that we get in performance with feeding them with feed-grade amino acids. And like I said, my opinion is that we'll be able to actually improve efficiency of gain. And we eventually would like to look at least costing carbon footprint in these situations as well, okay? Okay, I'll be happy to take any questions.